Hi everyone, in this video we are going to talk about multiple linear regressions. Multiple linear regression means you have access to more than one variables to be used to predict the response variable. So we are going to work on how much does your car worth. We are going to build a model and predict how much is your car worth. And the dataset is actually from a real example KBB of several hundred 2005 used GM cars. The variables in our dataset are price, mileage, make, model, trim, type, and cylinder, liter, doors, cruise, sound, leather. We actually have these many variables. Some of them are numerical variables and some of them are categorical variables. But our focus here, because we want to predict the price of a used car, so price will be our response variable, which is the y. And as you know, price is actually a numerical quantitative variable. So the model we are going to use is multiple linear regression because we have so many other variables available and we can use a specific combination to find the best model for predicting price. So now my RStudio is opened. I'm going to create a new R script. And then I'm going to import the dataset so that we are able to use it. And I'm going to click File, Import Dataset from Text Base. Then I find the dataset here, which is called car.csv, and I opened it. So you can see it from the data frame here. All the variables will be imported very nicely. So I'm going to just click Import, and the data is here, ready for us to use. And I often copy the line here so that next time when I open my R script, I just run this line to import the dataset. The goal here is to build a model to predict the price of a used car. And as we have said, price is a quantitative variable, which means MLR will do it. First of all, I want to do some data visualization, which is a very important first step to do. Data visualization can help you to see the data better, because if you look at the whole data set, you have no idea what is happening. Or after that, we are going to talk about different types of multiple linear regression. More complicated than simple linear regression. As you can see, you can build a model with, like, you just add up the variables together like this. Or you can have interactions, like your response variable with x1 plus x2 plus x3, and you may also want to have x2 times x3. And also, you may want to build a model with squared terms with each variable like that. And you may want to do some scaling of certain variables, or you may want to change the unit of certain variables. So there are so many different types of multiple linear regressions you can actually try. And you want to load the package ggplot2 so that you can use ggplot function on the dataset. The first plot I'm going to draw is the distribution of the car prices. So the aesthetic information, I assign S equals the price, and then I draw a histogram and I let the bins equals 30. So you can see the distribution of the prices, like here. And you can see this is kind of a right-skewed distribution, with most of the cars around $20,000, and some of the cars have much higher prices. And we can also explore the distributions according to like the make of the car. So we can do GGplot the dataset name, and then we assign x equals price, and we change the color according to the make of the cars, and then we add the histogram for each car, for each make. So you can see it here. We have a histogram, and we have different colors to show different make of the car. As you can see, the Saturn is like a very perfect normal distribution. And even the blue one, SAAB, they are nicely distributed here. But for the Cadillac, you can see they are higher price, and they are all on the like more than $30,000. Idea about how different the prices are for different make of the car, which also makes me think, okay, make is an important variable in predicting price. And to see it more clearly, you may do something like this. You may draw one graph for one make of the car. But everything is the same for the beginning. And then you just add a facet wrap, which means you are going to split the graphs into smaller pictures to see them more clearly. So you can see it here. You can see it like which make has a more normally distributed distribution, which make has a right skewed distribution, and which make has a lower price comparing with other makes, and so on. So all these informations are clearly shown in this graph. Then you may want to check scatter plot, like what is the relationship of the car price with a numerical variable. So you can let y equals price, and you can let x equals mileage, which is by common sense we would think like the more you use your car, the lower the price might be. And you can also show those colors according to the make of the car. And then we use the point, which is the scatter plot. So you can run this graph, and you can see it here, like the golden dots are Cadillac, and it has a very strong downward trend. But for the green dots, you can see the pattern is more flat. So you can see those differences, like how mileage is related to the price or is affecting the price for different make of the car. And if you want, you can also split the graphs into small pictures according to the make of the car. by run those 3 lines. See, you can find them here. Like the patterns are a little different for different makes of the car. So that's kind of the examples of the explorations you can make. And there is one package called GGally, which you can use to show like all sorts of different pairs of the variables in your dataset. So if you look at the dataset, we have numerical variables in the front, we have some categorical variables, and then numerical variables again, like the indicator variables, dummy variables, and we also have categorical variables like that. So you can actually show those relationships all at once by specifying data equals car, and the columns you want to check, you can specify them maybe the first 2 columns and then from this column to the end. So we can do 1 to 2 and then 7 to the last column is 12, so 7 to 12. And you can run this line to see the pairwise correlation graph. And you can see we have the distribution of each variable, although for the numerical variables, or for the dummy variables, they are not making sense. You know what? I'm actually bothered by seeing the distribution graph of doors, cruise, sound, and leather, because for the doors we know it's 2 or 4. For the sound and leather, they are actually binary variables, either 0 or 1. So it doesn't make sense to show the correlation of those variables with price as well as the distribution of a dummy variable. So I'm going to make changes to these variables by writing a for loop. So the variables are actually, so you can see it here, cylinder. Later is a numerical variable, so I'm going to change the column 7 and then column 9 to 12 into categorical variables. 7, 9 to 12. And I'm going to do it by using car, the ith column equals to the characterize the car of the ith column. So in that way, we can change that car dataset into the true variable types. Like cylinder is a categorical, doors and all those dummy variables, they are categorical variables now. And then I copy those lines, and we can actually see a better picture of the pairs. If you zoom the picture, you can see it and better now. So price with the doors, the binary variable 4 or 6 has a difference or little difference on the price. And for the cruise, there is a much larger difference. You can see the 2 boxes don't even overlap. And there may be some differences for sound and leather, but the differences may not be that significant. You can still see the price and mileage has a negative correlation coefficient. Price and liter has a positive correlation coefficient, and also for the cylinder, you can see there are some differences on the price because this box is much higher than the other 2. So this graph is much better than the previous one when we use the right type of the variables. And now let's try to build some models. So this video is not to help you find the best model, but to introduce you to different types of models you can build. So the first one is the easiest one. We can use LM price with mileage with cylinder, and then with how many doors you have on the car, and then the cruise, as well as sound, as well as leather, and then you specify the data equals car. So this is one model you can think of, and you can name it as MLR1. And you can run that, and then you can run the summary function on that first model you built. And you can see it here. A lot of the variables are significant, or you can think of it as significantly affecting the price, like this one, and this one. And you can see the multiple R squared value is 0.56, adjusted R squared is 0.55, and the F value has a very small p value, which means the model itself is significant. And then you can continue, like you can build a second model, also MLR, and you can add more variables to it. I'm going to copy everything here, but I also want to add another variable which is called make. So you can run that line, or you can run the two lines together, these two. And you can see, first of all, I noticed the multiple R squared value is much higher, adjusted R squared value is much higher comparing with the previous model. So that means the make is probably an important variable to be added into predicting the price. And you can see each category is actually very significant. Then other models you can think of just to play around is to add the interactions. So still Y is the price, and you can actually add mileage times cylinders, and then you add the make, because we noticed the make variable is very important. So this model is actually talking about, we add the mileage, we add the cylinder, and we also add the interactions between mileage and the cylinder. So you can also type MLR3 and run these two lines together. You can see, surprisingly, all the variables are significant, and the R squared, adjusted R squared are still high. And we have mileage, we have cylinder, we have mileage times cylinder, and mileage times the 8 value of the cylinder. But I also noticed one thing is, like, this one is 10 to the power 4, this one is 10 to the power -3. So it seems like the coefficients we are getting are very different, or either very large or very small. And that is because if you look at the car price, the prices are in dollars. They are very large numbers. The mileage are also very large numbers, but those other values here, they are very small. So that makes the coefficients are different dramatically. And one thing you can do is to create an improved model, name it as model 4, and you can scale the mileage variable. Scale, it means you can standardize that variable to the center of that variable value. So you can run these lines and you can get a model. You can see the same R-squared adjusted R-squared value, but the coefficients are not that dramatically different. And let me show you one thing about the scale. So if you run the summary function on the mileage, you're going to get the summary values of it, which has a mean of 19,832 and minimum 266, maximum more than 50,000. If you want to understand what does scale do, you can do the scale of mileage and then you can run the summary function outside that scale. And you can see it here. The mean is 0 and the minimum and the maximum are very small numbers. So when you do the scale, you are actually standardize the values. And another improvement you can do, because if you look at the coefficients, they are also kind of large and small. That is because the price is still are still very large numbers. So maybe we can have another improvement on the model and we can change the unit of the price. You don't really want to scale the price because you want to have predictions on the price. So you can actually change the unit of the price by adding an I, capital I, and then divided it by 1,000, which means we are changing the price unit into $1,000. And this is our model 5, and you can run that. Still, it will not change the R-squared values, but the coefficients are more meaningful now because the values are kind of small, close to each other, and you have a better idea about what is happening. So to visualize the model results, especially the model coefficients, you want to install a package called coefficient plot. So COEF plot. And install that package first and then load that package. And now we can visualize the models we have built. For example, you can use coefficient plot on MLR1, and you can have a graph here showing you like some of the coefficients are around here, some of them are around here. That is a line of 0. So you can see this one is more than 15,000. Those values are close to 0. You can also do multi-plot to compare the coefficients like MLR1, 2, and 3, and you can have the coefficients drawn on the same graph. And this is it. So the red ones are MLR1, blue ones are MLR3, green ones are MLR2. One graph I want to show you, which is our happiest model in the end, is the MLR5. And if you draw that graph, you can see the coefficients values are just from -5 to like less than 20. This result is more clearly shown how each variable or each category is affecting the price. Like which one is a positive effect, which one is a negative effect, and so on. So this is a better model for now.